Building games is difficult. We know this. But building games that are designed to be released on multiple platforms at once, well, that's a whole other problem. As any developer will know, getting your game running smoothly on one platform is the first part of a much longer battle. The next part is ensuring it runs as smoothly as possible on all the other hardware you want to release it on. And this brings us to Snowcap, a plugin built for Ubisoft's Snowdrop, the game engine used to create titles such as Tom Clancy's The Division, Star Wars Outlaws, and Avatar Frontiers of Pandora, that uses AI to estimate performance on different consoles, but without actually running them on the device.
Hey all, I'm Tommy Thompson, this is AI in Games, and yeah, this Snowcap tool is admittedly a little weird, but I'm going to do my best to explain to you how it works and what it is they're doing. Plus, we reached out to Ubisoft for more info and had the pleasure of sitting down for an interview with 3 of the developers behind the tool to find out how they built it, how it works, and the value it's bringing to their game production pipelines. In an age where questions are quite rightfully being asked about the value of AI in game development, Snowcap is, for me at least, one of the coolest examples I've seen of how to use artificial intelligence to support game developers, because it's helping not just speed up the process of porting games to other platforms, but it's helping developers anticipate and remove performance issues before they even deploy the game on the target hardware. Let's check it out.
So to get into the weeds of this, it's worth stressing the real problem that Snowcap is trying to solve, and that's helping support cross-platform development. As you'll know, when AAA studios ship a new title, it's typically released on PC and consoles at the same time. If you're porting to console, and assuming we're focused on the current hardware on the market in 2026, then that means you're working on the PlayStation 5, the PS5 Pro, the Xbox Series S and X, and now potentially the Nintendo Switch 2 as well. Each of these devices have very different performance profiles as a result of the makeup of their CPUs, memory, and GPU. Quite often, when larger studios have a game in development, they will have teams of devs focused on optimizing for each platform, addressing a memory issue on the PS5, dealing with GPU performance on the Xbox Series S, and so on.
Speaking from my own experience supporting games to consoles, this is a long process. You work on the issue, you make a new build of the game, you deploy it to the dev kit version of the console, and then begin to run profilers and other performance tests, all to ensure you don't wind up with a bad review over on Digital Foundry. Not that anything I've worked on has appeared on Digital Foundry, but you get what I mean.
Now, this is all par for the course in game development. But as I said, it's a long process. You can easily lose hours of development time rebuilding the game, deploying it to the hardware, and hooking up the profiling tools to check whether any incremental improvement has been made. And this brings us to Snowcap and how Massive used AI to help make that process easier. Snowcap is a plugin built for the Snowdrop engine that predicts in real time the performance of a game in the engine's editor based on a particular hardware profile and graphics preset. It achieves this using a trained machine learning model that is gathering a large amount of data about how games perform in the Snowdrop engine under a variety of conditions on the target hardware. And then the trained model can predict how well the current game in the editor would perform on that target hardware. As we see in this demo footage provided to us by Ubisoft, this version of Snowcap is predicting performance for the PlayStation 5, Xbox Series S, and Xbox Series X all at the same time, and it's doing it in real time in the editor. This is quite an impressive technical achievement, and we'll dig into the weeds on that shortly, but it's worth taking a moment to highlight that this is not just a technical innovation, but also something of a change in philosophy over how games are developed. As Franck Maestre, a senior engineer on the Snowdrop engine, explained to me, the tool started development when Snowdrop was being upgraded for the current generation of consoles, taking into account how Ubisoft's games are built and the changes that were occurring at that time in rendering techniques.
The idea of Snowcap was born while we were upgrading Snowdrop for the next generation of platforms. Basically, while we were upgrading the engine, we started to, let's say, some discussion with technical artists, world builders, rendering guys, with some people working on those new platform and new capabilities, new rendering techniques, object materials, we realized that just the old process of setting up budgets in a traditional way, I would say, could work at some extent. But as some rendering techniques are more expensive than others, it was introducing a level of complexity to get a deterministic overview of it and of the final performance very, let's say, random. So we started investigating the fact of injecting in-engine metrics very deep when you are defining world generation rules, object placements, avoidance, density. It's difficult to estimate the resulting GPU. In fact, workload of what you are doing without creating builds and running tests. Also keep in mind that it's Snowdrop, everything is not based, and technical artists, they can actually edit their object materials properties using node graphs, which means that our metrics should not be located at this level, the node level itself, but the renderer's underlying operations. Like rendering paths, amount of meshes, bypass, primitives sent to the def map, to the cascaded shadow map.
And in fact, it didn't start out with the ambition to be AI-driven. It was only after an internal demo was shown around the studio that Nikolai Stefanov, who is chief architect for Snowdrop and the technical director of the upcoming Tom Clancy's The Division 3, suggested this diagnostic process could be modelled using AI. This led to David Renaudie, an expert AI scientist at Massive, to join the Snowcap team and start exploring how to implement the machine learning model. But while the technical part is critical, as I said, it's also about the change in approach to how games are being built. We heard from Elia Wrzesniewski, an associate production director on Snowdrop, who explained how this is changing the way in which games are made in a more sensible way. Rather than letting performance issues creep into the game in ways that other automated tests would miss, only for them to be ironed out later, Snowcap helps developers become more proactive in nature, identifying problems as they arise when changes are made to the game, and try to minimize any immediate performance issues that could emerge as they go.
It's really about prevention, so it's a bit of a mindset shift, just like you described. You want to ship the features, you have a deadline to meet. So everybody's focused on gameplay, on features, and sometimes it can create that kind of bottlenecks on optimization later in the production cycle. And so here, yes, it's really the goal to prevent introducing unintentionally performance issues along the way, along the whole production, so you don't create these bottlenecks. And we on the Snowdrop pipeline, we had a very natural adoption from the game's production. And as you mentioned, Nikolai Stefanov, for sure the games he works on are also adopting this tech. But yes, we have a very good adoption. So people naturally see the benefits and are using it.
And as Elia elaborated, by reducing the number of regular or basic performance issues being added to the game, it allows for the QA teams to focus much more on finding issues that arise from regular gameplay, as well as what happens when you just let players loose and start causing chaos. So how does all this work? For any Ubisoft studio wanting to use Snowcap for a given game, they set up their own project definition file, which defines the performance parameters and technical specifications of the game, and this helps determine the expected performance at the end. In order to work both in supporting developers in the moment, but also providing more accurate prediction over time, Snowcap operates in two modes. The first is of course the performance prediction mode that we described, but also there is the data collection mode. After all, in order for it to predict the performance, it would be good to know how well the actual game you're developing works in practice on the target hardware, especially as the game itself begins to evolve and change over time. However, as described to me by the team, given so much of the data capture is focused on the engine itself, Snowcap is largely game agnostic. and instead is focused more on the version and configuration of Snowdrop. This means that over time they can curate datasets reflective of specific permutations of Snowdrop based on the range of render pipeline configurations and technical specifications that can be set.
It's pretty simple. There's the hook in the engine that is going to be activated on a basis that we decide for. So, of course, we sample the capture because we cannot capture this like 60, 80, 100 FPS for all machines during all their execution time. It would be like a huge volume of data, but it would be also kind of useless because we don't need actually all this volume of data. So to build it, to give you an idea, an order of magnitude, we gather millions of data points. It's really easy because we are at frame level. And we try to, we randomly sample them across a variety of hardware and presets. So we aim to have a good distribution of this data with all the targets that we want to use this prediction for. And then we use it to build a model for a given version of the engine. And regularly, since internal playtests are being done, we gather new data and we enrich the model, or we retrain it, and we make sure that we have no regression and so on and so forth. And then if another games, or when another games comes in, then we redo this exercise of making sure that we have the right metrics, because some rendering techniques differ from game to game. So sometimes we have to retrain specific models, and sometimes we can just reuse one out of the shelf that we already have.
But it's more than just running under the hood without any guidance. As Elia explains, Snowcap can be configured for specific setups and pre-configured paths in the game. In fact, if you recall way back in 2020 when we released a video about how Massive had built testing bots in Tom Clancy's The Division 2, including auto-testers that could run through the level based on a pre-built configuration set by the developers, well, now Snowcap can be attached to an auto-test bot so that when it gives data reflective of a player's normal playthrough, this can be processed into heat maps and other reports that can give the developers a much clearer insight into which parts of the game have performance issues and what might be the cause of it.
We also can set up or tweak the data tracking frequency to run what we call camera performance or auto-test path, so across an entire level. And so basically what it means is that the camera moves through the environment to automatically, it does it automatically. And from these data sets, we can generate heat maps. So it gives to the developers a clear picture of how the level performs. Even where it's interesting that even before gameplay elements are added, so you have an idea of your vanilla level, how does it perform. And it's also a useful way to spot potential issues very early in the game development to guide you to make smarter optimization decisions right from the start and not too late.
While we are talking about Snowcap now in early 2026, the tool has existed in Snowdrop for some time now and has been adopted in most projects built in the engine in recent years. In fact, I first heard about it in the summer of 2024, and in that presentation that was shown behind closed doors, we saw its ability to track GPU performance in a complex jungle biome. And it was highlighting two key things. The first is that it's predicting the frame rate based on the target resolution for the platform. The second is the level of dynamic view scaling that is being applied, which is when the game is in real time adjusting the rendering resolution on the fly such that the frame rate remains consistent. This is also useful given each project defines not just the desired resolution and frame rate for a given platform, but the limits of the dynamic scaling as well.
When we talk about GPU performance, it's not unidimensional. There are actually two dimensions of it. And this is what you see in this window, and it's let's say the entry point of the use of Snowcap in the editor. But if the user wants to say, okay, I need to dig a little more into details here, it's possible to open it into more a detailed view where you can see the evolution of all the predictions in time and with more complex graph here showing all the breakdown, all the details for the predictions. And side by side, the user can also see the engine metrics that are being actually used to make the predictions. This is already a first level of an entry point for investigation. The user can have a look at what's happening right now in the engine and have an idea of, hey, I have a predicted performance drop here. What should I be looking at? Oh, I see there is probably too many lights, too many particles, too many some things, and I have to act upon this. And this is again just the first level of entry, but we saw that it's still helping and speeding up.
But in addition to this, it can now show the engine metrics that are being used to make the predictions within the model. This can be useful for developers to more readily diagnose why there is a performance issue in a particular area of the map. But it's not just tracking aspects of the game that impact GPU performance, such as the number of meshes and tries within those meshes that are being rendered. But it's also tracking CPU objects as well, courtesy of an integration with Snowdrop's performance analytics pipeline. This is of great use given many CPU-bound aspects of the game will also potentially have GPU implications as well.
We integrated to Snowcap a CPU part. We have data coming from this pipeline that we can see in editor, and we can see if an entity performs well at this place instead of this place or this place or this place and this place. Because depending on the context, being in the wind corridor where, let's say, if you talk to physics guy, when you are in the wind corridor, a constant force is applied to the object, so the rigid body for the object will activate and generally deactivate on collision. It will cost, and actually on the frame rate war, we have two winners that can break the frame rate. Is the GPU, which is the most important for us, because this is where we try to anticipate things, but you got the other one, which is the CPU, and the worst will win the battle of trigger a warning about frame rate drop. So,
but we will still have edge cases because the system are so complex that even if you have a clean map, gameplay there, but even if everything is clean, there will still be a probability that something goes wrong if the player, I don't know, opens everything, put too many explosions in a specific location. So I think it also relieves some bandwidth for QA to really try to break the game and find these edge cases. And the developers, they can also be more confident, knowing, okay, here I did my level, I create my heart, and I know that it should run properly on target console. But yeah, games are so complex today that even with these tools, I think it's still difficult to. We will have edge cases to find. Yeah.
So, of course, the one thing that is worth bringing up, and I think David would be heartbroken if we didn't put it in the video, was just how big, how complex, and how expensive this model is. I'll let him explain.
Something that I think will be interesting for your audience is to mention that we went the way of neural networks, artificial neural networks, but we didn't go in the deep neural network direction because it wasn't actually needed. In the early experimentation phase, we tried with simple feed-forward neural networks, and I'm going to tell you, just without telling you about the architecture or anything, the size of it. So, today we are in a world where it's the big race, among the big actors of biggest model in terms of billions of parameters and so on. Snowcap model is running over a hopping 18K parameters. So 18K parameters, which is approximately making it big as 80 kilobytes. And it's running. Why is it interesting? That it's still, going very well in terms of accuracy for the prediction. We have less than 4%, even 3.3%. I think it's what I showed at the conference error rate, so which is really good. But it also runs in real time on the developer's workstation without impacting the frame rate on the said workstation and at frame level. So this level of having a really lightweight model and super well integrated in the engine, I think like really valuable also.
You're right. I should have asked you this question because it's also you clearly watched the last episode we put out, which was the ML Move project.
Yes.
Which
excellent one, by the way.
I was
so you're smaller.
Too.
Yeah, your model's smaller. Compared to ML Move, that was what, a 21 megabyte, couple of million parameter model. 18,000 is nothing. Like
it's nothing. And still is doing the job.
Both Snowcap and our recent deep dive on ML Move in episode 81 are a nice reminder that contrary to the narrative surrounding AI these days, we can often solve complex problems with simple yet well-considered solutions.
You don't need a complex ML model to solve sometimes even complex problems like this. When you tackle the problem, say, oh wow, it's really not simple, not something we can easily solve, or we might need a big model and so on. Sometimes not. So it's really, I think here the learning is also interesting from that point of view. We can solve this type of problem with really lightweight model that just do the job, and it's beautiful. Simple is beautiful.
You know, having made these videos for over 10 years, it's not often an idea comes along that catches me by surprise. But Snowcap is certainly one of them. A really innovative way to apply AI to support game developers in a sensible and practical way, allowing developers to get on with their day-to-day job, but helping them find the issues in their work faster and more readily, such that they can do their best work first time around, rather than having to go back and fix it later.
Plus, it's clear as the range of platform specifications grows, with new platforms coming to market, be it new consoles, new handhelds, or even potentially using this to benchmark certain PC profiles, tools such as Snowcap can help streamline the process of porting these games and ensuring they run smoothly. And if this means we get a lot more big AAA games running really smoothly on portable platforms, then I'm all for it. A huge thank you to David, Elia and Franck for sitting down to chat with us, plus to David Antel and Joe Morange from the PR teams at Massive Entertainment and Ubisoft for supporting us with this project, including giving us permission to share some of the behind-the-scenes footage of Snowcap in action, as you've seen in this video. That's it for this one. Thank you so much for watching. Stay safe, take care, and I'll be back once I've played a bit more of Star Wars Outlaws. The Switch 2 port is really good. I mean, no, this episode wasn't sponsored by Ubisoft. It's just I'm having a good time going back and playing this game again on the Switch 2. And, cross progression. Get in.